In Unit 6, we start looking at what are called functions and the idea of a structured program. And in Lesson 1, we're going to talk about what is a function so that you know exactly what I'm talking about when I refer to a function. These are also sometimes commonly called methods, so I might sometimes use that word interchangeably. And then what on earth is a structured program? By the end of this lesson, you'll be able to divide a large program into small problems that can be solved in chunks, and then you'll also be able to write a Python program as a function, and you'll also be able to write little programs or little functions in order to help you reuse code in Python. So when I begin talking about structured programming and the purpose of functions, I always start by having students think about planning a wedding and think about some of the steps that are involved when you're planning a wedding. So I know that none of you are married, but think through some of those things that might be involved. What might you have to do in the process of planning a wedding? So maybe jot some ideas down. What are some things that you're going to have to do? It's a pretty big undertaking. It's a pretty big project. So just think about it for a second and write some ideas down. So I'm sure that the ideas that you thought of for things you have to do when you plan a wedding were similar to what you see on the screen. You might have something different or something additional, but the big things: you have to make a guest list, you have to do your photos, decide on your wedding party, find attire, meet with the pastor, food, decorations, rehearsal dinner, everything like that. There's a lot that goes into planning a wedding. And what's difficult with a wedding is if you try and plan it all at once, you're going to fail. But if you break it up into small problems to solve, it actually makes the whole process a lot easier. And that's the whole idea behind modular programming or structured programming, as you'll see on the next slide. The whole idea behind a structured program is that we break it up into these small problems. We tackle one thing at a time. You don't try and do every single thing, but you break it up into little mini segments that you solve separately and then tie together at the very, very end. Just like a wedding, where you plan things separated and then they all tie together for a wonderful event at the very end. So a structured program is this idea of organizing a program by breaking it up into smaller, easier to manage programs, which are called functions. So that's why functions and structured programming are tied together, because at the end of the day, a structured program is really by breaking it up into small little functions. It allows you to reuse code that is repeated, which is great. And the other thing it allows you to do is divide and conquer a program, just like a wedding. How you divide and conquer it in chunks, you don't conquer it all at one time. So it's this idea of breaking it up into smaller problems and then solving one little problem first, a little problem second, and a little problem third. It has this idea of what's called a top-down design. So you take a large program and you break it up into smaller and smaller subtasks that go to the bottom. So it's this big program here, and then you break it up. And you might break it up further and further. Maybe that one's just once. But you break it up, and it's this idea of making it smaller programs so it's easier to tackle. And as I said before, this is also called modular programming because you're breaking it up into modules. You're breaking it up into these little functions that solve particular tasks. But that's in its essence what structured programming is. It's organizing that program into smaller functions that make it easier to manage and easier to solve. At this point in the course, I start to get a lot of questions of, well, why do I need to learn this type of programming? I already know how to program. The problem is that the older types of code, so the code that we used in the past, was pretty much like spaghetti. And you would be coding, and then you would jump here, and you would do something, and then you jump back, and then you jump here, and then you jump up here, and you'd run this again, and then you jump back up here, and you'd run this again. And there's no flow to it. So the programs we've done so far are pretty simple. Once they start to get more complicated, you have to start structuring it in a different way in order to make your program function. And the older way of doing it before they discovered this structured programming was basically spaghetti code where everything was all intertwined and you jumped back and it was confusing. Our modern way of programming is what structured programming is. And what it allows you to do is have one main function where your main code runs in a logical, easy to understand order, and then you have other functions that always return to the main. So you have these little functions, these little sub-programs. Oh, sorry, disappeared there. But you have these little sub-programs that essentially your main program will run here and it'll go, and then it calls a function, so it runs a little bit here and it jumps right back. And then it goes again and it runs this program. So it's out here, and then it jumps right back. So it's much easier to understand. It's always having a main function that goes step by step by step by step by step, and then it's got other little side programs that will return a value and go right back to where you were. And you keep going step by step by step. And this will make more sense as we get started programming in Python. So the main steps we're going to take as we write a structured program. The first thing is we're going to start with an outline of the main program. So my suggestion is to write out some sort of pseudocode to describe the major tasks being performed. Avoid thinking about the details right now. Just think, this needs to happen first, second, third, fourth, fifth. Say these are the main things, the major tasks that need to happen. Then your main function will consist of mostly calls to little subprograms, those little mini programs or functions that your main function can call. So basically, maybe you're finding the area of a trapezoid and you need to get the values from a user, then you need to calculate the area, then you need to print the area to the screen. Those would be good times to have 3 different functions. And the other big thing is as you're writing your main, you need to have good documentation or good comments so that the person reading your program knows what is happening. But those are our first 2 steps. Start with an outline, and then write the main, which is mostly calls to other functions. Then from here, you actually write each function. So you define the function with its name and parameters, and you type the code for that function indented. And we'll see what that looks like in a couple of slides. But you write each function so that you can call it in your main. And then the fourth and final step is to test and debug it and make sure it's working as necessary. Because as your programs become more complicated, you're more likely to make some errors, and you're going to have to catch them and debug those before you have a final product. So here on the screen, I want to give you an example of the planning process. So here I'm pretending I'm going to write a program for the area of a trapezoid. And so I start off by thinking, okay, what are my major tasks? Well, my major tasks are that I first have to introduce them to the program. That's my first major task. My second major task is that I need to have them enter in data. The third is that I need to have them calculate the area. And the fourth is that I need to output my results. So those big tasks that I have going on, those 4 big tasks are my 4 functions that I could write to make this program structured in structured programming. So I would write one method or one function that does the intro, one method or function that does the data entry, one that does area calculation, and one that outputs the results. So those are my big functions that I'm going to create in order to run this program. Then from here I thought a little bit of extra, and I thought, okay, what's the data I need? Well, I need a height, base 1, and base 2. I could also make a note here that calculating the area is area equals 1/2 times height times base 1 plus base 2, etc. So I can make comments about each little mini function, but the idea is I start by thinking of the big problem, and then I break it down into mini subprograms so that I can solve each little piece one at a time. Then once I have that decided, what I would do is I would start writing out my main. So I would have, okay, definition main, which I'll talk about that line of code in a second. And then from here, my code of my main would mainly consist of calls to these different functions. So maybe I'd have an intro function that I would call. Maybe I'd have a data function that I would call, an area function that I would call, and an output function that I would call. And so see how my main function is made up of these little mini functions here. And then I would write each one of these separately as well. I would write my intro function. So I would say, okay, well, my definition for my intro function, this is what it does. And I would write the code for that. Write the code for the data function, the area function, and the results function, so that I could then use them here in code. And I know that you don't really know what this exactly means yet, but this is the main idea behind it. Plan out the whole thing. Decide what functions you need. Your main function will call these 4 mini functions here, and then you'll write those 4 mini functions separately. Now, as a side comment, before we start coding our own functions, you've actually used a ton of functions already. So when we were in Turtle Graphics and you were using forward, color, left, right, backward, etc., those are all functions. When you're in the math, import math, and you're using all of these, those are functions. When you're printing or getting information from a user, those are functions. With all of the string functions we used, those are functions. The random numbers, we've used tons of these so far, and you can identify them by those parentheses at the end. And we're going to talk more about what these values on the inside represent, but all of these are functions that you've used in the past. So they're already pre-written by Python, and this chapter is about writing our own. So as I already kind of said on the previous slides, a function is a subprogram or block of code that accomplishes a very specific task. So this could be an intro. This could be getting data. This could be calculating area. This could be outputting. Whatever it might be, it's going to accomplish one small task. It's not a big picture thing. It's a small task. Oftentimes, we'll return a value that will be what Lesson 3 is about. And it's often just a miniature program and something that's also called a method or a subroutine. But it's just a mini program that allows us to accomplish a small task. It's just going to have one job. Not many jobs like the main function, just one job. It calculates area. It gets data. It prints to the screen, whatever it might be. It has one small job, and then we call that function to do its job. So the syntax you see on the screen is what function code looks like. And we're going to start defining our main function in this way, as well as all of our little functions. So this definition part is what tells you that it's going to be a function or a new function. So when we define our main function now, we're actually going to start every program with define main. And then we're going to put the parentheses after with a colon, and then all of our main function statements will go inside of here. So notice how it's indented code, but this definition tells us that this is a function, and we're going to do this even with our main function. So in the next video, you're actually going to code happy birthday. It's going to use that definition main function. Now, in order to run that main function then, because it's in this definition part, is you actually have to put the code main parenthesis at the bottom to run it. Now, I know this seems a little inconvenient because you have to add extra code in, but in the end, it makes our programs much, much easier to use. Now, from here, any functions that we write will have the same type of look. You will still have the words definition, and then you'll have the name of that function. So for example, in the last program, we could do definition intro. If we wanted a function named intro, we get to pick our name. We put the parentheses in, colon, and then we have all of our statements inside of there. So we could have a print statement that prints some sort of intro to the user. So notice how this is indented, but this is a very short function that has a specific job to print. You could also have one called maybe area, and maybe that one will calculate your area. So notice how it's definition, the name, and then the statements are all indented from here. We're going to write every single function this way, including our main function, and you'll see that as we start that happy birthday program in the next video.